Welcome to SS2 Further Mathematics, Term 3, Week 16. Mechanics is the branch of further mathematics concerned with the study of forces and motion. In this lesson we revisit vectors and forces at a higher level, using vector notation, resolving forces in 2D and 3D, finding resultants, and applying equilibrium conditions to solve problems involving particles. By the end of this lesson, you will work fluently with vector notation for forces, find resultant forces, apply Lomy's theorem, solve equilibrium problems, and answer WAEC further mathematics mechanics questions. Let us begin. A vector has both magnitude and direction, a scalar has only magnitude. Notation: a vector can be written as a bold letter or underlined A, in column vector form, A equals, ax, I, as a magnitude and direction, A equals at angle theta position vector. The vector from the origin O to point P is the position vector of P, written OP or A underscore P. Unit vector, a vector of magnitude 1. Unit vectors in 2D, I equals 1, 0, horizontal, and J equals 0, 1, vertical. A vector A equals ax, I equals ax I plus ij, magnitude, A equals square root, ax superscript 2 plus I superscript 2. Direction, theta equals arctan, I slash ax, adjusted for quadrant. Addition, A plus B equals, ax plus bx, I plus by. Subtraction, A, B equals, ax, bx, I, by. Scalar multiplication, co equals, cax, k. Unit vector in direction of A equals A slash A. In 3D, 3 unit vectors I, j, k along x, y, z axis. A equals ax I plus ij plus azk, A equals square root, ax superscript 2 plus I superscript 2 plus az superscript 2. Dot product, scalar product A, B equals A because theta equals ax bx plus I by A in 2D, equals ax bx plus I by plus az bz in 3D. Perpendicular vectors, A B equals 0 left right arrow A up tag B, parallel vectors, A times scalar equals B left right arrow A is parallel to B. A force is a vector, it has magnitude, in newtons, and direction. Resultant force, the single force equivalent to all applied forces. A equals F plus F2 plus F, vector sum. Component method, 2D resolve each force into horizontal, x, and vertical, y, components, Fx equals F cosine theta, Fy equals F sin theta, where theta is measured from the positive x-axis. Some x components, Ax equals sigma Fx, some y components, Re equals sigma Fe. Magnitude of resultant, I equals square root, Rx superscript 2 plus Re superscript 2. Direction of resultant, alpha equals arctan, Re slash Rx, adjusted for quadrant. Worked example 1, forces of 10n at 0 degrees and 8n at 60 degrees and 6n at 150 degrees. X components, 10 cosine 0 degrees plus 8 cosine 60 degrees plus 6 cosine 150 degrees equals 10 plus 4 minus 5.196 is equal to 8.804 n. Y components, 10 sine 0 degrees plus 8 sine 60 degrees plus 6 sine 150 degrees equals 0 plus 6.928 plus 3 is equal to 9.928 n. I equals square root, 8.804 superscript 2 plus 9.928 superscript 2, equals square root, 77.51 plus 98.56, equals square root 176.07 equals 13.27 n. Direction equals arctan, 9.928 slash 8.804, equals arctan, 1.128, is almost equal to 48.5 degrees from positive x-axis. Equilibrium, a particle is in equilibrium when the resultant force is 0, sigma Fx equals 0 and sigma Fe equals 0. This gives two equations to solve for unknowns, e.g. unknown forces or angles. Lomy's theorem, for a particle in equilibrium under exactly 3 concurrent forces P, Q, are P slash sin alpha equals Q slash sin beta equals A slash sin gamma, where alpha is the angle between Q and A, opposite to P, beta is the angle between P and A, opposite to Q, gamma is the angle between P and Q, opposite to R. The angles are the angles between the forces, measured with the forces pointing away from the particle. Lumy's theorem only applies when exactly three forces act on the particle. Worked example 2. A particle is in equilibrium suspended by two strings making angles 40 degrees and 50 degrees with the vertical, with a weight W equals 20 and acting downward. Find the tensions T and T2. Three forces, T, along string 1, T2, along string 2, W equals 20 and downward. Angles between forces, angle between T and T2 equals 180 degrees to 40 degrees, 50 degrees equals 90 degrees. Angle between W and T2 equals 180 degrees to 50 degrees equals 130 degrees. Let me use components method instead. Horizontal, T sin 40 degrees equals T2 sin 50 degrees. T times 0.6428 equals T2 times 0.7660. T equals 1.192 T2. Vertical, T cos 40 degrees plus T2 cos 50 degrees equals 20. 1.192 T2 times 0.7660 plus T2 times 0.6428 is equal to 20. 0.9131 T2 plus 0.6428 T2 equals 20. 1.5559 T2 equals 20. T2 equals 12.85 N. T is equal to 1.192 times 12.85 equals 15.31 N. Friction force F equals mu N, limiting friction, where mu is the coefficient of friction and N is the normal reaction. On a horizontal surface, N equals W, weight. F underscore max equals mu W. On an inclined plane at angle theta, normal reaction N equals W cosine theta, component of weight along plane equals W sin theta. For limiting equilibrium on incline, F equals mu N equals mu W cosine theta equals W sin theta tan theta equals mu, angle of friction lambda equals arc tan mu, angle at which a particle on an incline is on the verge of sliding. Moment of a force about a point, the turning effect of a force. Moment equals force times perpendicular distance from the point to the line of action of the force. Unit, Newton meter, Nm. Direction, clockwise, negative by convention, or anticlockwise, positive. Principle of moments, for a rigid body in equilibrium, the sum of clockwise moments about any point equals the sum of anticlockwise moments. Sigma m underscore clockwise equals sigma m underscore anticlockwise. And, sigma fx equals 0, sigma fe equals 0, the three conditions for equilibrium of a rigid body in 2D. Worked example 3, a uniform beam of length 4 m and mass 10 kg rests on two supports at positions 0.5 m from each end. Find the reaction forces. Beam weight equals 100 n at center, 2 m from left end. Let I equals reaction at left support, 0.5 m from left, R2 equals reaction at right support, 3.5 m from left. Sigma Fe equals 0, R plus R2 equals 100. Moment about left support, x equals 0.5 R2 times 3 is equal to 100 times 1.5, clockwise, adjusting for positions, R2 times 3.5 to 0.5 equals 100 times 2 to 0.5, 3 R2 equals 150 R2 equals 50 N, I equals 100, 50 is equal to 50 N, by symmetry, equal reactions, expected for uniform beam on symmetric supports. Key points, vector, magnitude plus direction. Component form, F equals Fxi plus Fyj, F equals square root, Fx superscript 2 plus Fy superscript 2. Addition, add components. Resultant of concurrent forces, Rx equals sigma Fx, Re equals sigma Fe, I equals square root, Rx superscript 2 plus Re superscript 2. Equilibrium, sigma Fx equals 0, sigma Fe equals 0, and sigma m equals 0 for rigid bodies. Lumy's theorem, three forces only P slash sin alpha equals Q slash sin beta equals R slash sin gamma, friction, F equals mu n, and limiting, on incline, N equals W cosine theta, max friction equals mu W cosine theta, moment equals F times D, perpendicular distance, principle of moments, clockwise equals anticlockwise in equilibrium. WAEC test, resolve forces into components, find resultant magnitude and direction, equilibrium problems with two unknowns, Lomi's theorem, friction on horizontal and inclined surfaces, moments, beam/lever problems.